Good morning, everyone. Myself, Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the regulation of 2021. Let us start with the basics. What is Embedded C? First, we all know about C programming language. When we use a normal C language to program embedded systems like microcontrollers, washing machines, traffic lights, medical devices, then it is called as a embedded C. So simply C language plus embedded hardware is equals to embedded C programming. It is mainly used to program microcontrollers like 8051, ARM, PIC controller, AVIA, etc. Then what is the difference between C and embedded C? Let us see the difference between the C and embedded C. Normal C is nothing but it's a general purpose programming language, and whereas the embedded C is a subset of C language. And the C program, it runs on the computer. It is whereas the embedded C is specifically used for embedded systems. In C, we use compiler to convert C program into machine code. Whereas in embedded C, we are having the cross compiler. What is cross compiler? It is the compiler that runs on one system but generates code for another system. That is the microcontroller. So that is the main difference. In this C programming, the compiler is used to conversion of program from C to the targeted language. That is the machine code language or a machine language. Whereas in this embedded C, we are using cross compiler, which is nothing but it generates the code for another system. So, what are the keywords? Let us talk about the keywords. The keywords are the reserved words in C. We cannot use them as a variable names. For example, int, character, float, double, while, long, void, etc. The important point is all keywords should be written in a lower case. This ANSI support, ANSI, ANSI, C supports such 32 keywords. Then what is identifier? These identifiers are user-defined names. That means names given by the programmer. For example, variable names, function names, labels. Then what are the rules for that? It should start with the letter. It can contain letters and numbers. So this is the main thing, and only the special characters is allowed in the underscore. Okay, it should not start with the number. This is the main reason for the identifier, and it's the main example for the identifier. For example, its valid is total mark or count. This is the valid, and the invalid is one count. That is the invalid one. Then data types. We already studied about the data types in C in the previous video. Here also we are having the data type. Tells what type of data a variable can store. For example, integer is it stores integers, and a float it stores the decimal numbers. Character it stores characters. The important note is in embedded system, the size of the data type may vary depending on the cross compiler. What is cross compiler? Which is I already told you no that cross compiler. The size of the data type may be depending upon the cross compiler. We are giving compiling one set of program for the another device. That's a microcontroller. So because different microcontrollers have different memory sizes. Then storage class. What is storage classes? In this, the storage class tells about the scope of the variable. I am highlighting that scope because the scope of the variable where it can be accessed. Then the second one is lifetime of the variable. How long it exists in the memory. These are the two important keywords. First one is scope of the variable where it can be accessed, and the second one is lifetime. Lifetime means existence, how long it exists in the memory. And the C supports four storage classes. What are the, it is the auto, extern, static, and the register. This, for example, the static variable retains its value and the extern is used for global variables. Next one is branching instruction. Branching means changing the normal flow of execution. There are two types of branching. One is conditional branching and the other one is unconditional branching. This condition branching, execution changes based on the condition. In unconditional, execution changes without any condition. In the conditional example, for the example of conditional branching is if, else, switch. Because if in switch, if we on the equipment or load, if we on the switch, the fan will rotate. If we off the switch, the fan will off. So depending upon the condition, the execution works, the execution changes. This is the conditional branching. And then unconditional means, for example, go to, break, continue. So these are the examples of unconditional branching. So next one, these are the branching, conditional branching instruction and the explanation. This is having a if statement. This evaluate the expression first. First, we are having if expression. And if it is true, it executes the statement given in the braces. This is open braces, the statement 1 and statement 2. Then continuous execution of statement following the close curly braces. This if statement is true, then it goes for a statement 1. Then it goes for a statement 2. And it goes for the statement 3. And it goes for the statement before the end of the curly braces. And it skips the execution of the statement within the curly brace if the expression is false. And if the expression is false here, then it will continue the execution of the statement following the closely curly braces. Do you understand this? In this conditional branching, if statement, we are having if statement. In this if statement, we are having expression. If this expression is said to be true, then this will move on to the next to the open braces, open curly braces. Then it execute the statement 1. Then it execute the statement 2. Then execute the statement, next statement, and the output will come depend upon the if statement. If the if statement is said to be false, then the statement 1, statement 2 is nothing to be happened, it's nothing to be executed. It directly comes to the statement 3. This is the execution of statement following the closing curly braces. So this is the one-way branching. This branching, this continuation, this evaluate the expression first and it gives a true executes the statement given within the braces following the expression and the continued execution of the statement following the closely curly braces of else book. Executes the statement within the curly braces following the else if the expression is false and continue the execution of statement following the closely braces. Then these are the reference and what are all the topics we discussed today. What is embedded C? What is the basics of embedded C? And the difference between C and embedded C? And what are the keywords present in the embedded C? And what are the identifiers, data types, storage classes, and branching instruction? There are the two types of branching instruction. We have seen clearly about the branching instructions. Okay, these are the basic foundation of embedded C. In the next class, we will see with the practical example and the next topic. Thank you. Thank you for watching the video.